Okay, so today's topic is weak entities. So I'll start with the last question that I gave to you that we'll discuss first. So I asked you a question in our last video that which entities in a college can survive alone. That means which entities cannot survive without a parent entity. Yeah. So I would say so. The thing is a course. Yeah, a course. Which courses? Like, can you think of some courses which can exist alone without students, zero students enrolled? Any new elective course, like any elective course, which nobody has opted, but it is still a course in the curriculum. Okay, so those kind of entities. So that course can become a, you know, an entity without any students. Hmm. Okay, then a professor on some leave, I would say on sabbatical. That means a paid leave or partially paid leave. That means he or she is not having responsibilities. He or she is on some break, but here he or she is still a part of the department. So a professor who is not teaching for this particular semester, but is a part of the department. Okay, so this is also one entity, a professor, which can exist without any workload. Yes. Okay, but a student can exist with no department? No. So student needs some entity. They cannot survive. Student cannot survive. Okay. Yes. A payment with no loan, it will become meaningless. So that entity. So payment is one entity which cannot survive alone. Student is one entity which cannot survive alone. But course, an elective course, a professor on a leave, they can survive. Yeah. So the ER model has an exact notation for each of these situations. When we will draw these ER models, there are representations for that. And that's today three new tools we are going to discuss: participation constants, key constants, and the star of the show, our weak entities. Very much asked question in the Vivas. So let's go further and explore this part. Correct. So that we are going to discuss one by one. Yeah. So first we'll discuss about our participation constants. Total versus partial. Now see, look on the left side. Professor and course connected by professor and course connected by teachers. Correct. Yeah. Some professors are on a leave, suppose. Some are on deputation. Some only do research this semester. So they participate in no teaching relationship. And that's perfectly valid. And that is called as partial participation. Okay. So that is called as partial participation. So their notation will be an ordinary single line. So any types of professor we are counting over here, deputed professors just doing research this time, no teaching workload, professors on leave, any type of professors, they are teaching some course. Okay. So they teach no course this semester, still they are valid to be an entity. Okay, because they're part of the department. Now look on the right hand side. Look on the right hand side. Now here what is happening, we have two entities, student and department. So is there a single student in your college who belongs to no department? Can you think of anyone? Impossible. So the moment you are admitted to the organization, you are in some department. Every single entity in student must participate. That means all the students of this entity must be a part of some department. So that is called as total participation. That is called as total participation. And we mark it with double line. I hope you understood this part. Okay. So you have to do some brainstorming. You have to think about it, how things happen. So as we are going further in ER diagrams and we are making it full-fledged and fully developed with all the functionalities, then it becomes little complex, and you have to give it time to think which entities can have partial participation, which entities can have, total participation. Then you do these representations. So this is partial participation, this is total participation. I hope you got some idea. So one detail students get wrong constantly is what? The double line goes to the side that must participate, not across the whole relationship. So here you have to remember this part. You have to identify that entity which has to participate completely. Yes. Okay. So every student needs a department, but a brand new department could exist for a moment with zero students admitted yet. Okay. Yes. Correct. So a new department can be launched, but it is not necessary key immediately it will have students. Yes, but students, whenever they are getting admission, they have to be a part of some department. That is total participation. Great. So let's see further. What are the things? Yes. Okay. So our next part of this is key constant. Okay. So here what is happening? That is our next second tool, and let's be very quick in this one. So sometimes we need to say at most one, and for that our ER model will use an arrow. Okay, at most one. At most one. Please make a note of this. So whenever you think of this part, then we have to represent it with an arrow, an arrow notation. So department is headed by some professor. Can one department have two heads? No. So we draw an arrow pointing to the professor. Okay, at most one. Okay, maximum it can be only one. Department headed by, because the relationship we are taking here is head. So there will be only one head of the department. And if you want to show that in your ER model, we have to show with the arrow, because it is showing it can have at most maximum one professor only who will be represented as the head of the department. Okay, so here is the decoder that you can remember. Arrow is at most one, double line is at least one. Double line plus arrow, exactly one. So this new combination also to remember. So double line plus arrow will show exactly one. Okay. That third combination is how you express exactly one, mandatory. And examiners will be asking you this while seeing your ER diagram. So if you have utilized this functionality, please remember their definitions, and remember their one examples. That will be useful to you. Okay. Okay. Now the main part, weak entities. Okay, some entities which cannot survive alone. Okay, so we have to see this now, and it is one of the main part of this video. So suppose, let's draw some real situation, not a definition. Suppose we are taking a bank loan, and you repay it in installments. So we have to give some installments. We have a bank loan and we have to pay some installments, and suppose it is happening in the form of 1 2 3 and go on. So we make a payment as our entity set. Let's make this payment as an entity set. Okay, and obviously the key is payment number. So what will be the key attribute? That is prime attribute is what will be the key attribute? Think of it, payment number. Suppose in this way I am right. So this is our key attribute. Okay. So is payment number 3 unique in the whole bank? Think of it. Think. So see, you can ask yourself, is payment number 3 is unique in the whole bank? So there will be different loans. Loan number 101, loan number 102, loan number 103. They all are having some payments. So 101 is also having payment 3, 102 is also having payment 3, 103 is also having payment 3. So is it a unique one for the whole bank? No, it is not unique. So there are lakhs of payment number 3 in that bank. So if I walk in and say, show me payment 3, the clerk will ask, which loan? Payment 3 of which loan? Yeah. So payment 3 means nothing on its own. It only makes sense payment 3 of which loan number. Yeah. Yes. And here is the main part. So the entity set with no key of its own, an entity set with no key, it is not having any key attribute of its own, is called as a weak entity set. It's called as a weak entity set. It doesn't have its own key. Fine. I hope you got this. If you have any doubts, please drop a comment. So this entity set cannot identify itself. It must borrow identity from somewhere else. So this payment has to borrow this identity P number from the loan. So it cannot have this key attribute. And an entity with no key attribute is called as weak entity. Great. So I hope you got this. Great. Let's discuss further about this part very quickly. Okay, fine. Now here what happens is, what is a notation for our weak entities? So everything will be represented in the form of doubles. Okay. So double rectangle, double relationship, double diamond. Okay. That is the thing. So here it is actually easy to remember because there is only one rule to remember the notation for weak entities. Everything doubles. So weak entity gets a double rectangle. That is your payment. Payment will be shown as a double rectangle. You can see. So this is the representation itself. The reader will know by itself. Payment is a weak entity. It is a weak entity. And its pay number is shown with dashed line. That means it is dependent on the parent entity, that is loan. Okay, that is the meaning. So double rectangle means entity is weak and it has no key of its own. Great. So the relationship that gives its identity, that is called as identifying relationship. Identifying relationship, which gives its identity. So that is represented with double diamond. Double diamond. That is the relationship we have taken as loan payment. The lines get double too. So total participation is required, and that I will explain in a moment why that is guaranteed. Okay. So see, the attribute that is almost a key, payment number. This, it is almost a key, but it is not a key. Okay, it is almost a key represented with dashed line. Is unique only within one loan. It is unique only within one loan. Please remember these things so that it will help you out to, think of different types of weak entities, because this is just one example. You have to think of many ones like this. Yes. So it is called as partial key. This is called as partial key. Please remember this term. Okay, so Viva can be like, what is partial key? And it is also called as discriminator. So can discriminator. Okay. Okay, fine. So it is having a dashed line. It is called as partial key. It depends on the loan. It is unique only inside one loan. Okay, so fine. So we got everything double. Here total participation is required. Relationship is identifying relationship, that is double diamond. Entity is double rectangle, that is weak entity. and the attribute, the key attribute is almost a key attribute, not a complete key attribute. So it is noted by dashed line, which is called as discriminator. Good. For any doubts, please drop some comments. Now, see, why we say it is a total participation? Why always total participation? So let us understand this part. So why is the participation of weak entities is always a total one? Why not it is a partial one? Because the reason is the weak entity borrows its identity. It borrows its identity. Okay, please make a note of it because it is borrowing from which one? From the strong entity. Yeah. So your strong entity is loan and your weak entity is payment. So it is borrowing. It is borrowing from the loan. So this is a strong entity. This is a weak entity. With the help of identifying relationship. That's why. Now see, loan number plus pay number. That is the owner's key plus your partial key. Together, they form the full identification, basically. So if you want to check which payment is being done, so how will you see? First, you will check the loan number. Then you will see the payment number. Then it will give you the correct information. So that's why the weak entity cannot exist alone. Okay, it cannot exist. So that's why the line is always double. Its total participation is required. So if you will delete the loan and every payment of that loan becomes meaningless data, that is a meaning. Yeah. So it acts like a child. It acts like a child with the parent. So that's the sentence to remember. And you will see this in your Viva a lot. What is weak entity? How to represent a weak entity? Can you give one example? Very much asked question. Okay, great. Okay, fine. So let's move further with this and let us explore further in this part. So we have some differentiations and it has been asked a lot in the exams. What is the difference between strong versus weak entities? So this is the comparison table I kept for you. Please note it down in your notebook or keep a screenshot of it. Strong entity has its own key, single rectangle, ordinary diamond, solid underline, participation may be partial, and weak entity, no key of its own, double rectangle, identifying double diamond, dashed underline, and always total participation. Fine. So you have to remember it like this. You'll never make mistakes in the strong entity and weak entity. So it can be asked for a 3-mark question max. Now let's see. This is all about our entities and our 3 tools that we have discussed. Now see what is happening. Now same pattern everywhere once you will see it. Okay. Building and room. So we have these two entities. Okay. So room 101 exists in every building. Room number alone is not unique. Correct. So you suppose you have 3 buildings. Every building will have 101 as a room number. So room itself cannot become a strong entity. So room number alone will be useless. You need building plus room number. So here what will happen? Your room will become what? Weak entity. Great. Got it. And this is your strong entity. In the same way, order and order item. So if suppose you are ordering something on Amazon, every single order has an item. Item 1, item 2. So line number repeats across millions of orders. This is item 1, item 2, item 3. Correct. So line number will be the partial one and it always needs your order ID. Great. The next one, next another example can be employee and dependent. Okay, so here suppose employee and dependent. Now, without the employee, the dependent record will have no meaning. Okay, suppose any employee is there who is employee have different responsibilities. Suppose you have someone working under you. Suppose any employee is working on some funded research project. Okay, so they hire some GRF, and suppose that project is being cancelled, or that employee who has got that funded project left. Then without that employee, that dependent cannot exist. He or she is existing because of that employee. So in that case, dependent name will become partial, and they always need the main employee's ID. Okay. So I hope you got the clarity on all these topics. Now, finally, let me conclude this, and here is your turn now. Suppose I'm giving you a question. You have to think of an hotel booking system. A hotel has many rooms. Room number 3 starts at 101 in every hotel. Every room must belong to a hotel. Each room has a type and a rate. So you have 4 questions. Which entity is a weak entity? How do you know? Draw it with the correct double shapes. What is a partial key and how it has been underlined? And is the room side total or partial? Okay, so take your time, draw it, pause the video, and then I'll show you the answer. Fine, pause the video and do it by yourself. Here is an answer. So room is your weak entity. I hope you got it right. You must have understood it. And its room number will become your partial key. And the total identifying relationship will be represented with double diamond. Hotel has rooms, and hotel will have the main primary key. And this room is completely dependent on this hotel. So this room number cannot exist without the hotel. Great. Great. I hope you got the answer. Fine. Finally, I have some questions listed out which can be asked in exam, like what is weak entity, draw some neat ER diagram with example, explain participation constraints, total and what is the difference between total participation, partial participation, differentiate between strong and weak entities, what is partial key, how it is represented, what is identifying relationships. These are all small questions and can be asked in short notes also. And please make a note of these things and keep practicing. Then only you'll remember, because ER diagram is having too much. If you'll go deep down, it is having too much to discuss. And once you will start making ER diagrams, which we are going further to do, I'll keep one complete session on that, how to draw a complete ER diagram with all the functionalities. So let's move further. Now, lastly, in the video, a question for you before I close the video. Question for you is, student has a name, ID, address. Professor has also a name, ID, and address. Staff is also name, ID, and address. Now 3 rectangles repeating the same address. Aren't they all really people? What do you think? What do you think? Can't database inherit properties? Think about it. So think about this part and give your answers in the comments. We will discuss it in our next lecture. Thank you for watching, students, and your subscriptions, your comments, sharing my videos. It is all a complete motivation to me to keep running this channel. Thank you for your support. Thank you for becoming my fan. Thank you so much. See you.